Okay, so now we're going to show that f of x equals 1 over x is its own inverse. And what I'd like you to do is I'd like you to pause the video here, and I'd like you to do f of x and see if that equals x. Go ahead and try it. Okay, so I went ahead and did f of x, which is 1 over x, which is 1 divided by 1 over x, which is 1 times x, which is x. And yes, so f of x is indeed its own inverse. Okay, so we're going to find the inverse of h of x equals x over x minus 1. Remember, change h of x to y, and then, so that's y equals x over x minus 1. So once you've done that, then switch the x's and y's and solve for y. So go ahead and do that, pause the video, and then come back and look at the solution. Okay, so follow along here, and we'll say that y is equal to x over x minus 1. We switch the x's and y's, and then we basically cross multiplied here, and we got yx minus x is equal to y. Then I just simply solve for x. Okay, so I took this value over here, and so I took let's see, y times 1 minus x, or y minus yx is equal to negative x. So I subtracted this yx over here, and then I factored out the y, and then I divided, and I solved for this. So h inverse of x is equal to negative x over 1 minus x. Now I could manipulate the minus sign and multiply by negative 1 over negative 1, and it would change it to x over x minus 1, but either one is okay. All right. So a graphical interpretation is that an inverse function is a reflection of the original function in the line y equals x. So basically it's sort of like folding the paper or folding your graph along the line y equals x here, and wherever it reflects across that line, you will get the inverse. So if you visualize this as a series of points, this square root function here, it looks like some kind of function, weird looking function. Anyway, I think it's a square root function. And so if we think about, we've got the point 1 comma 0 and 5 comma 2. If I reflect those, I'm going to switch the x's and y's, and I get 0 comma 1 and 2 comma 5, right? So if I go to 2 and then up to 5, I'm going to get this graph that looks like, basically we have a shape that looks like this. And that's it. Okay? All right. And here on example 6, basically what you've got here is you're looking at f of 0 equals 1 and f of negative 1 equals 2. So these are two points that are on this function, 0, negative 1, and negative 1, 2. So if we take the inverse of negative 1, f inverse of negative 1, that's going to give us the value. This is like you're just switching this value with this value, so now this will be 0. So the inverse of f is 0, okay? And then what is f inverse of f of anything? It's got to be x, so 0. So f inverse of f of x, if the two functions are indeed inverses, then whatever's plugged into this here is always going to be this value, the result of f inverse of f of that value. So it's just a matter of that is x, so whatever value you're plugging in. And the same thing's true the other way. We said that f of g of x or g of f of x would be x if those two functions are inverses. And since these are defined to be inverses, this is 2. And that's it. Go on to the next video.